Good noon, everyone. Today discuss about computer-aided process synthesis. Unit number 4, synthesis of heat exchange and networking. On a previous lecture, to start the temperature interval and minimum utility targets ના આપણે method જોઈ ગયા હતા. Then after some basic information for a graphically system for graphically problems ના સ્ટેટમેન્ટ જોયા હતા. એના બેસિસ પરથી આપણે એક જોઈશું એક્ઝામ્પલ મેથડ કે કઈ રીતે એક્ઝામ્પલ સોલ્વ થઈ શકે એ પ્રમાણે. ઓકે, તો સ્ટાર્ટ કરીએ આપણે ફોર બેઝિસ in a temperature interval method and also minimum utility target. Okay, the first one is there on a data basis. Okay, the cold stream C1 and C2 are to be heated. What happened? Okay, the cold stream C1 and C2 are to be the heated and a two hot stream H1 and H2. Simply on this basis C1 and C2 on a hot stream H1 and H2 આપ્યા છે. Okay, are to be cooled without phase change. The condition and properties are as follows. જે આખા ડાયાગ્રામ આપી છે તમને ટેબલમાં આપી છે ટેબલ ફોર્મમાં. ઓકે, ધીસ વન એનો ડેટા જોઈ લઈએ આપણે પહેલાં તો. સ્ટ્રીમ્સ આપે છે કોલ્ડ ફેઝ 1, કોલ્ડ ફેઝ 2, હોટ ફેઝ 1 અને હોટ ફેઝ 2. એના ટેમ્પરેચર ફેરનહીટમાં છે 120, 180, 260 અને 250. ઓકે, અગેન સ્ટ્રીમ્સ આપણને આપ્યા છે C1 બેઝિસ, C2 બેઝિસ, H1 બેઝિસ અને H2 બેઝિસ. એના ટેમ્પરેચર આપણને અલગ અલગ આપ્યા છે તે આવી રહ્યા ટેમ્પરેચર. ઓકે, દેન ટેમ્પરેચર T એના ફેરનહીટમાં અલગ રીતે બંનેના. ઓકે, તે આપ્યા છે આ રીતે. ઓકે, હવે એના કેલ્ક્યુલેટ પ્રમાણે જે આપણે ફાઇન્ડ આઉટ કરીએ છીએ એ પ્રમાણે એનું છે ધીસ વન MCP M into CP specific gravity into 20,000, 40,000, 30,000 and 50,000 and Q rate of heat transfer in a Q 10 to 4 BTU per hour, 230, 240, 300 and 180. Okay, it is the assume that the heat capacity, the flow rate MCP is equal to C. Okay, the heat capacity આપણને આપ્યો છે MCP is equal to C, this one આ સ્ટેટમેન્ટમાં. Okay, which is the product of the specific heat and mass flow rate does not vary with the temperature as shown later when it is necessary to account for variations in the heat capacity with the temperature also. Okay, a stream is described into the interval and the substances. Okay, and each involving a different segment of the temperature range and a different C on example 10.5. Okay, જે આપણે જોવાનો છે this one example આગળ the composite curve method and 10.4, this is a 10.5, this one for a marginal minimum requirement for a targeting for a process exhibiting phase change and a variable heat capacities. Okay, એનું સોલ્યુશન આ પ્રમાણે છે તે આપણે જોઈશું કે હાઉ ટુ સોલ્વ ધીસ ઇન અ ગ્રાફિકલી સિસ્ટમ. Okay, then in example 10.5 basis પણ આપણે સોલ્વ કરીશું. And the heat exchange and networking, the use of the smallest amount of heating and the cooling utilities possibilities such that the closest approaches temperature difference is never the fall below a minimum value. Okay, for the minimum utility method. Okay, and for a heat exchange and networking, heating and cooling utilities possible માટે such that the closest approaches temperature for difference is never fall below a minimum values for the temperature range in this example a reasonable assumptions in the delta T minimum is equal to 10 Fahrenheit. Okay, delta T minimum આપણને કેટલા આપ્યો છે 10 Fahrenheit આપ્યો છે. Okay, then વિચ છે એઝ્યુમ કર્યું છે કે હીટ કેપેસિટી ફ્લો રેટ કેટલો છે આપણો એમસીપી ઇઝ ઇક્વલ ટુ સી છે. હવે આ ડેટાના બેઝિસ પર આપણે ગ્રાફિકલ સિસ્ટમમાં જોઈશું કે એનો ડેટા કેટલો કેટલો આવે છે એ પ્રમાણે. ઓકે, તો સ્ટાર્ટ કરીએ સોલ્યુશનમાં. ફોર ધીસ સિસ્ટમ, this one, for this system a total of 480 into 10 raised to 4 BTU per hour must be removed from the two hot stream, but only a total of 470 into 10 raised to 4 BTU per hour can be consumed by the two cold streams. Okay, hence from the first law of thermodynamics, a minimum of 10 into 10 raised to 4 BTU per hour must be removed by a cold utility such as cooling water. As shown below, this is not the minimum utility uses, which from the second law of thermodynamics depend on the delta T minimum. Okay, which possibly the heat exchanger networking is shown in a figure 10.3. Okay, a figure આપ્યું છે 10.3 માં આપણે જોવાના છે. This one. Okay, involving the 6 heat exchanger, 57 into 10, 57 into 5 into 10 raised to 4 and 67.5 into 10 raised to 4 BTU per hour of hot and cold utilities, for respectively not the difference between the hot and cold utilities duties equal the given by the first law of thermodynamics basis. Okay, which one? For this part you have properly completed discussion part. This one, શું કીધું છે? cold 1 phase, cold 2 phase and 2 hot stream H1 અને H2 are to be cooled without phase changing. કોઈ phase change થતો નથી. હવે MCP જે કીધું છે આપણને કે assume the capacity of the flow rate MCP is equal to C, which is the product of the specific heat, and the mass flow rate does not vary with the temperature. As shown later, when it is necessary to account for a variation part, heat capacity with a temperature, a stream is described into the several substances, each involving the different segment of the temperature range and a different C. For example, 10.5 માં જોવાના છે આપણે. And assign heat exchanger networking that use the smallest amount of heating and cooling utilities for a possibility, such that the closest approach on temperature differences never fall below a minimum value. For the temperature range in this example, a reasonable assumption is the delta T minimum is equal to the 10 Fahrenheit. Okay, in this basis for the system on this graphically. Okay, the example proposed for a heat exchanger networking for example 10.1 with a delta T minimum and only 10 Fahrenheit, showing interior for a heat exchanger 1, 2, 3. Okay, 3 heat exchanger આપ્યા છે 1, 2 અને 3, and the auxiliary exchanger for a hot and a cold phase, the multiplied duties for Q by 10 raised to 4. Okay, એના અલગ અલગ ટેમ્પરેચર આપ્યા છે તે જોઈ લઈએ આપણે. જો first one is a first one, second one, third one. Okay, આ બાજુ hot phases heat exchanger, આ બાજુ cold phases. બરાબર, અલગ અલગ એની વેલ્યુ આપી છે. Then, since the design of this heat exchanger networking has neither considered the minimum utility targets basis and a minimum number of heat exchanger, though not utilizes the procedure in the heat exchanger networking synthesis. Okay, since the design of the heat exchanger, the neither considered for a minimum energy requirement. Okay, and targets for not to utilize for a procedure or optimal heat exchanger networking synthesis. It the assessment focus on the two questions: how do the heating and cooling utilities duties for 57.5 into 10 raised to 4 and 67.5 into 10 raised to 4 BTU. Okay, to compare with the minimum energy requirement for targets B. Okay, it is possible to the synthesis heat exchanger networking. The favor the heat exchanger, and if so, what are its utility requirement? In this section, the first these two questions is addressed with the Second, which involve the higher utility cost and decreased capital cost. The postpone until the later parts. Which one? The first one, A. This one. How due to the heating and cooling utilities duties of 57.5 and multiply 10 to 4 and 67.5 into 10 to 4 BTU per hour. The compare with the MER, minimum energy requirement. Okay, marginal vapor rate આપણે જોયું છે. Okay, and the B part, it is the possible to synthesize a heat exchanger networking with a favor heat exchanger, and if so that what are its utility requirements in this section. The first of these two questions is addressed with the second basis of this involving which are utilities cost and decrease capital cost, the postpone until later, and their method are introduced to estimate minimum energy requirement. Okay, the first one is temperature interval method, જે area છે. Second one, a graphically method using composite heating and cooling curves, and the formation of the linear programming problems, જે આ છે. Okay, first one, which one is third one? The first one is there. Temperature interval method, minimum utility target આપણે જોયું છે મેથડમાં. સેકન્ડ વન ઇઝ ધેર ગ્રાફિકલી મેથડ યુઝિંગ કોમ્પોઝાઇટ કર્વ મેથડ, જે આપણે જોઈ ગયા છે. અને ફોર્મ્યુલેશન એન્ડ સોલ્યુશન ઓફ લિનિયર પ્રોગ્રામિંગ. ઓકે, હવે ગ્રાફિકલી મેથડમાં આપણે પ્રીવિયસ લેક્ચરમાં જોઈ ગયા હતા કે એમાં કુલિંગ માટે સિમ્પલી ગ્રાફિકલી કર્વ સિસ્ટમ અને હીટર માટે ગ્રાફિકલી સિસ્ટમ, અને હીટિંગ અને કુલિંગ માટે બંને માટે જોઈ ગયા હતા આપણે. બરાબર. તો ટેમ્પરેચર ઇન્ટરવલ મેથડનું આપણે ડિસ્કશન કરીએ. The temperature interval method was by Linhof, of this scientist name. The method is applied to the hot and cold streams in introduced to the example 10.1, and as will be seen, the procedure unfolds for determining the minimum utility requirements, overall possible heat exchanger networking, given just the heating and cooling requirement for the processes and stream, and the minimum approaches the temperature in the heat exchanger on the delta T minimum. This is the temperature interval method. What is the minimum utilities? This one, minimum utility targets. A principal objective, the synthesis of a heat exchanger networking. This one. In the efficient utilization of energy in the hot process streams to heat cold process stream. Thus it is desirable to composite the maximum energy recovery. Okay, and the minimum hot energy requirement. The before synthesize in a heat exchanger networking, that is the determine the minimum heat energy recovery, minimum hot and cold utilities in the network, given the heating and cooling also requirement part of this process stream. This is important for the first step is referred to the maximum energy requirement together targeting in the useful in that the terminate and the utility requirement for the most of the thermodynamically efficient in networking. To introduce the targeting steps, the example provided by the Linhof and the Turner is presented here. This example involve only sensible heat. Later example are presented to the also involve the latent heat and phase change also, and the heat of reactions under their either isothermal non isothermal conditions na basis પર. ઓકે, તો આ બે વસ્તુ જોયું અને આ એક પ્રોબ્લેમ જોયો સિમ્પલી. ઓકે, for this assumed only heat capacities for a flow rate MCP is equal to the capital C, which is the product of this specific heat and the means of the flow rate, does not vary with the temperature as shown in the letter, when it is necessary to amount of for variations of the heat capacity with the temperature. A stream several in the YouTube each involving a different segment is for a temperature range and a different C. In example this 10.5 also. The sign of heat exchanger networking, the use of smallest amount of the heating and cooling also. The possibilities of closest approaches temperature, this one. Okay, the below in a temperature is a only delta T minimum is equal to 10 Fahrenheit also. Okay, simply what is the data when is equal 480 into 10 to 4 and 470 to 10 to 4. और delta T minimum આપણે 10 Fahrenheit લીધો જ છે બરાબર, and the 6 heat exchanger in this basis. Okay, simply temperature ના basis પર. Okay, તો next lecture માં આપણે ટેમ્પરેચર ઇન્ટરવલ મેથડના જોઈશું અને લિનિયર પ્રોગ્રામિંગ માટે જોઈશું. Okay, તો thank you so much.